let's continue with powers, the units and powers. Let's solve this. Remember, identify first or try to simplify the numbers. We have already in scientific notation. Perfect. So let's see if we have in units any prefix. We can identify the prefix kilo and we can identify the prefix milli. But in this one, see, we have seconds square. So that means that is hidden here one parenthesis. So in order to simplify all these units, we are going to write carefully the prefix kilo, that means times 10 to the 3, and we have meters, and here the parenthesis that is hidden, milliseconds square. Don't forget this for power. Okay, let's write it now. 7.8 times 10 to the 2 is going to be up to you if you want to keep that power in that position or move to in front. I'm going to move outside, so I'm going to have meters here, and this one change for the power of 10 associated to this prefix times 10 to the negative 3, and I have seconds, and don't forget that square. We try to solve things from inside to outside, so the innermost power of 10 that we have here is this one. So we already tried to simplify these powers. Multiplication with the same base, we add 2 plus 3, and we have meters, and we have powers with powers multiplication, so that means times 10, negative 3 times 2, and we have seconds to the second power, or 1 times 2. Okay, now if we keep simplifying, 7.8 times 10, 2 plus 3 is 5. We have meters, and we have here minus 3 times 2 minus 6. 1 times 2, 2 seconds square. We can write in this part, let's see, we have an integer and a fraction. So whenever we have to deal with things like that, let's use the properties. Keep the power of 10. Let's express the power of 10 divided by 1, and it's an integer at the end, and we are going to have meters times 10 to the minus 6 seconds square. Fraction says numerator times numerator and denominator times denominator, so we can express this one in this way, times 10 to the 5 meter, and times 10 to the minus 6 times 1, so it's not necessary to write it, seconds square. And you can see that we can solve division with the same base. So we have division with the same base, we subtract the power of the denominator, so it's 5 minus 6 because it's negative. And we have at the end the units meters per second square. So 4 power. Okay, right in here we have 7.8 times 10 negative times negative is going to give me positive, so it's 5 plus 6 meters per second square, the 4th power. Okay, this is going to be the same, like to be writing 7.8 times 10, 5 plus 6, 11 meters per second square. And we still have the 4 power. So finally we have scientific notation, the basic units in the international system. Meters per second square are unit for acceleration, that is meters for length, seconds for time. No more prefix, so we can go outside to the next. The next is the power that we have been carrying all this time. This power is involving all this, so it's going to affect to the number, the power of 10, and the units. So 7.8 going to be to the 4 power times 10 to the 11 to the 4 power, and meters per second square to the 4 power. The same. So 7.8 to the 4 power is going to give me a big number, 3,701.5056. Now, powers and powers we multiply. So we have times 10, 11 times 4. And powers with powers are affected. So we have meters, 1 times 4, and seconds square times 4. At the end, (11 times 4, 44). We have 1 times 4, 4 meters 4. 4 times 2, 8. Okay, we can keep this is going to be our answer, or keep moving our decimal point. Remember to use the inverse ruler of powers of 10. We have 0, minus 1, minus 2, 1, 2. So probably if we are already here 44, that means that we are going to have 45, 46, and keep going. So if we are going to move our decimal point until we get scientific notation, it's going to be 44, 45, 46, and 45, 46, 47. And the units, meters 4, seconds to the 8 power. This is going to be basically the best answer that we have. Let's try to solve one more example. Now, suppose that we have again, for example, a big number like 4, 9, 3, 1, 0, 0, 0, 0, 0, 0 times 10 to the minus 5, and we have some prefix like a centimeter square. Pay attention to that. On deciseconds, and we power this one to the third power. It looks very big. Remember, step 0, breathe, relax. Step number 1, try to simplify. A lot of zeros, we try to reduce. So scientific notation is going to be the most simple expression. Let's see. if we start to count using the inverse ruler, keep in hand that in inverse ruler we have the negatives in that direction and we have the positives in that direction. Let's start from here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be times 10 to the 9 power. In front, we are going to have times 10 to the negative 5. Now, let's focus in the units and let's see what we have. In deciseconds, we don't have power, so basically we can perfectly write the units. Deci is times 10 to the negative 1. And we have second. But here we have a prefix, units, and also a power. So that means it's hidden one parenthesis there. So don't forget that. Write the parenthesis. I'm going to replace right now the prefix centi times 10 to the negative 2. We have meter. And don't forget that we have power at it. Let's try to keep simplifying. We have multiplication with the same base. We can write like this. For multiplication with the same base, we add 9 plus minus 5. For the units, remember, this is going to affect to every single term that we have inside. So it's going to be times 10 to the minus 2, and powers with powers, we multiply. Meters 1 times 2. So we get rid of that power, but still we need to simplify this a little bit more. Positive times negative, so it's 9 minus 5, 4. We have minus 2 times 2 is going to be minus 4. 1 times 2 is 2. Okay, from here I can use the properties from numerator affect only the numerator, or simplify directly here. So I'm going to choose to keep working in this little part of the fraction, only to have the fractional way for my units. And for division, we know that we subtract the power of the denominator. The power is negative in this case, so don't forget that we are going to have a multiplication of signs. So negative times negative is going to give me a positive, so it's minus 4 plus 1. Keep simplifying. So because we already have everything in numerator, it's going to be addition of power. So I'm going to finish with this part. Minus 4 plus 1 is negative 3. Multiplication with the same base, we add the exponent. 4 plus minus 3. Four minus 3 is 1 meters squared per second. It's going to be up to you if you remove this one, but I want to keep the power of 10. Remember that when you have in scientific notation, that is the most simple expression, and we have the most basic unit in international system. Meters squared is a unit of area, seconds a unit of time. We are ready to go outside. The next element, pay attention to the power. This power is involving the number, the power of 10, and the units, so it's going to affect everyone. 5.931 to the power times 10 to the 1 to the power. Powers and power, remember that we multiply. Or let me write like this to be more simple. And meters squared seconds to the third power. So 5.931 to the third power is going to be approximately, I'm going to start to round, 208.633 and more digits. Now 1 times 3 is 3, so we have times 10 to the third power. And we have powers with powers, remember, for the units. So meters squared times 3 and seconds, that is 1 hidden there, times 3. So it's approximately 208.633 times 10 to the third power, and we have meters, 3 times 2, 6, 1 times 3, 3 seconds to the third power. Right now we have a very simple expression. We still can move our decimal point. See, we are already in 3. Use the inverse ruler of powers, we are here. If we want to move our decimal point to the left, it's going to be more positive. So it's approximately 2.08.633 times 10 to the 3, 4, 5 meter 6 seconds cubic. That's going to be the most simple way to express this. With that, we finish powers, physical units whenever we have powers. Have questions? Please don't hesitate to ask in class.